In this problem, they has asking to find the voltage across this capacitor, right? The voltage across the capacitor, they has given what they has given. They have given two sources is given, the two different sources, and they ask into frequencies are different frequencies. Whenever the two different frequency sources are given, then we need to go for the superposition theorem. We need to do so. In that cases, we need to consider one source at a time always. Whenever the more than one sources are given, we need to go for the superposition theorem. We need to go right here. This frequency, in this case frequency given as a 5, in this case frequency given as a 10. So consider one source at a time. Consider one source at a time. Now let us say first case we are considering the voltage source. Now here consider that is 20 sine and t. This source we are considering. So we need to deactivate other sources and deactivate other sources, and we can redraw this network. We are considering only this voltage source only. We should deactivate other sources. And what is this other source here? This inductor is there. And what is other source is a current source. How we can deactivate the current source? By a open circuit. So do this open circuit, and this is how much it is, 20 sine and t, and this is 1 and this is 1 h now, and they given this as a 1 farad. Now let us call this voltage across this element where I want to find this voltage. I can say as a V1 of t. Now they has given this inductors and capacitors. Whenever they given the network inductor and capacitor, first you convert the inductors and capacitors into resistors form. Inductors or capacitors into what form? Resistance form. How we can convert the inductor, that is given L. What is the units of inductor? Is a Henry. So how we can convert the inductors into resistance form, as that is J omega L. Now what are the units are? Ohms. And capacitor, how we can convert capacitor? Farads na units. The capacitance we can convert into resistance form as what? 1 by J omega C. Now the units are ohms. Now the units are ohms. Right. Now I want to find V1 of t. So here you can see now there is no flow of current here. This is an open circuit now. So from this I can get my V1 of t. I can get now here. Get this V1 of t. V1 of t. First we'll convert into resistance form now here. So how we can convert this resistance form as a J omega is 10. Now this is what? Minus J by 10 now. Now this is the ohms. Tell me this value now here, V1 of t, which is voltage division we can apply. This is what we can say here, minus J by 10 by 1 minus J by 10 into 20 sine 10t. So from this what I can say, V1 of t, which is given as minus J 20 sine 10t upon what? 10 minus J. So this thing, how much will get this thing? V1 of t. So this is V1 of t, which is equal to what I can say here, this amplitude is how much it is, 20 by square root of 101 into sine of 10t. Minus j means minus pi by 2, and here this denominator angle is how much it is, 10 minus j. This amplitude is root 101, and this angle, what I can say, this angle is given as minus tan inverse of 0.1. So that will become to numerator, so it will become plus tan inverse of 0.1. This is my V1 of t. What is the V1 of t? V1 of t, voltage across the capacitor only when this source, when 20 sine 10t is acting alone. Now we need to find the response because of the other source also we should find now. We did the response because of this 10 sine t we did. Now we need to find the response because of this 10 sine 5t also we should do now. Now we'll see this thing, how we can do this thing. Consider this network again. We need to find the response because of this second one when the other source is acting. What is the other source is now? Consider consider 10 sine 5t. When this source is acting, then tell me now. So we should deactivate other sources, has to be deactivated now. What is the other source we have? Voltage source. How we can deactivate the voltage source? By a short circuit. This the voltage source is shorted. And how much is current value? 10 sine 5t, and this is 1. This is 1 farad. This is given as a 1. Right, we have deactivated by the voltage source by a short circuit like this. Now we need to find this voltage across this capacitor again. This voltage I can say as what now? V2 of t I can say. Again we should convert this inductors capacitors into what form? Resistance form. We can convert inductors as a j omega, capacitor as a 1 by j omega c. So do convert here the frequency, how much it is, a 5. Frequency is 5, so it will becomes what it is, a j5 ohms now this one, and this is how much it is, a minus j by 5 ohms now here. Now this current is coming like this, and this current is coming like this. This current is how much? 10 sine 5t. Then after coming here, the current will be divided for this part, and this part will divide now. If I call this current is I, now I can get this I now here. Now I can get this I here. Tell me this I can directly write this V2 of t, which I can write it as what it is, minus j by 5 into I can say. So from this V2 of t, which is given as minus j by 5 into I, the current division we can apply now. Yes, tell me the current division now here. 1 by 1 minus j by 5, yes, into 10 sine 5t. Right, so this is my V2 of t. So this V2 of t, do simplify it now carefully. So it is, what will get, minus j 10 sine 5t by, so take LCM and do simplify now here. So what I will get then here, this is 5 minus j now. So this amplitude is how much I can say it is 10 by square root of what, 26, and sine of 5t minus pi by 2. Why minus pi by 2? Because of this minus j means phase angle is minus pi by 2, and then plus tan inverse of b by a na. So it is b by a, so it is 1 by 5 means 0.2 na, this thing. So, and coming to this problem, what they are asking, so this is the V1 of t is the voltage across the capacitor when one source acting. V2 of t is a voltage across the same capacitor when second source acting alone. The total voltage is given as what we can say, the sum of these two voltages now here, the V1 of t, which is given as how much it is, 20 by square root of 101 sine 20 minus pi by 2 plus tan inverse of 0.1 plus 10 by square root of 26 sine 5t minus pi by 2 plus tan inverse of 0.2 angle. So now see this problem, what they ask me to finally, in this case they ask me to find only this a1 a2. a1 a2 is nothing but this coefficients only now here, a1 a2. What is a1 a2s are? Those are nothing but coefficients only now. So this a1 a2, get this a1, so I can say, let us say this is my a1 and this is my a2, I can say. So a1, so check this a1, I can say now here a1 value, a1 will get approximately, I think so 2, I think so, and this a2, so this is 1.96. so this is my final answer. In this problem, what are things we should focus here? Here the thing is, the first thing is, here they given two different sources are given, two different frequency sources are given. So we need to apply the superposition theorem, we need to apply. That is one point you have to remember. And what a second point is here, so whatever the inductors or capacitor they has been a problem, first of all convert the inductors and capacitors into resistance form only. Inductors we can convert the resistance as j omega L, capacitor we can convert as resistance means 1 by j omega c. Now after converting them the inductors, capacitors, resistors, now those are not a inductor capacitor. Now then after that you should treat them as a resistances only. Whatever the operation we can do, if in case of a resistor, the same operation we can do for this also. Fine.